Welcome back to Maths with Mrs. J. We've been talking about probability distributions and in particular about probability density functions of continuous random variables. Try to say that 5 times quickly. Now we're up to the point where we are going to learn how to calculate the median, which of course is your 50th percentile, and also in fact any percentile that you might like to calculate of a particular probability distribution. The median is, of course, your 50th percentile. Your lower quartile, sometimes referred to as Q1, is your 25th percentile because 25% or a quarter of the schools are below that. Your upper quartile, sometimes referred to as Q3, is the same thing as your 75th percentile because 3/4 of your scores are below that. If you have a value P here, in the form such that from P down to negative infinity of your function gives us this value Q, then P is called a percentile. All right, it depends on what Q is as to what percentile that is. If Q is 0.9, then P would be the 90th percentile. If Q is 0.5, then P would be the 50th percentile, which is the median. I'm going to do a couple of examples here. Here's an example where we have the duration of telephone calls at a large company, right? A continuous random variable X minutes with this probability density function. Clearly that is a probability density function. It's always at the X-axis or above. You can satisfy yourself that the area under the curve does equal 1. We're not going to do that at the moment. If we wanted to find a value such that 90% of phone calls last less than that number of minutes, how would we do it? Well, obviously the only values or the only section of the graph that we need to be concerned with is values of X above 0. So we're talking about from 0 to A of this function integrated is going to give us 0.9 as our probability. Okay, let's go ahead and work out what this integral is. So it's a third. Well, really, it's just negative e to the negative x on 3 from A to 0, isn't it? Because when you do differentiate that back again, the third's going to come out and the negative's going to come out. When we sub in, what we're going to get is negative e to the negative a on 3 minus negative e to the 0. Well, e to the 0 is 1 and that was a plus, all right? So putting it all together, we've got e to the negative a on 3 is 0.1. I'm actually going to change that to a positive index and say, well, if e to the negative a on 3 is 1 over 10, then e to the a over 3 is 10. Now I'm going to put that into log notation. So that tells us that a over 3 is natural log of 10. So a is 3 times natural log of 10, which is approximately 6.908. Now, it is appropriate to get an approximation for this question because it's a real life situation. Nobody's going to thank you for giving you an answer 3 natural log 10. They're going to say, well, okay, what does that mean? So getting an approximation here as well as the exact value is perfectly appropriate. So we'd say, therefore, 90% of calls last less than approximately 6.9 minutes. And there you have it. All right, let's do another example and see what we come up with there. So here's an example where we are actually calculating the median, bearing in mind that the median is your 50th percentile. So half the scores are below it. So in technical terms, your median is such that from negative infinity up to m is 0.5. But again, as we usually have, the function is really only above 0 when x is between 0 and 1. So in effect, what we're working out here is the integral from 0 to m of that being 0.5. Okay, so we're going to get 2 times x minus x squared on 2, just integrating that from m to 0 is 0.5. So 2 times m minus m squared on 2, well, that's just going to be minus 0, is going to give you 0.5. So 2m minus m squared equals a half. That is a quadratic equation, isn't it? So I'm going to pop it over the side that will make m squared positive. So I've got m squared minus 2m plus a half is 0. That will not factorise using your normal factorising techniques because your discriminant, b squared minus 4ac, is not a perfect square. So we would need to use our quadratic formula to work out what m is. Just to remind you, again, we're bringing in stuff that we've learned in previous years. So this will be 2 plus or minus square root 4 minus 4 times AC will just be 2 over your 2. So we get 2 plus or minus root 2 all over 2, which is approximately, now the first one you're going to get about 0.293, and the higher value you're going to get about 1.707. We don't stop there. We should always check both our answers for feasibility. This one, yeah, that makes sense. That is between 0 and 1 for our x. So that one is feasible. This one, 1.707 is greater than 1. This part of the function doesn't exist for that x value. So this one is not feasible as x is between 0 and 1. So our answer is going to be this one. So we'd say, therefore, the median is approximately 0.293 of whatever it is. Okay.